Welcome back to The Explainer. Today we are looking at something truly paradigm-shifting. We're going to examine the white papers, internal business plans, and the core strategy behind a fascinating company called Subvertio AI. We're looking at a fundamentally different approach to hardware here. This is an architecture built specifically for a world where energy isn't a bottleneck, but a boundless, virtually unlimited resource.
Okay, let's dive right into this. What if AI processors actually had unlimited power? I mean, right now, every transistor, every cache, every interconnect in traditional chips, it's all dimensioned around strict power ceilings, right? We live in this era of engineered scarcity, completely dominated by thermal throttling and incredibly strict power budgets. But the foundational premise of Subvertio AI asks a pretty radical question. What happens when we just stop optimizing for power and remove those constraints entirely?
Because honestly, our current engineered scarcity leads us straight to a staggering metric: 50 million. That is the number of tons of global e-waste we're generating every single year. The source material points out that the industry essentially locks consumers and data centers into these forced 2 to 3 year hardware refresh cycles. New GPUs demand new motherboards, new power supplies, totally new thermal envelopes. Entire systems are just scrapped for single-digit performance gains. It's a highly extractive economic cycle of planned obsolescence.
And the contrast in business models here is stark. On one side, you have the traditional NVIDIA model, right? It's constrained by grid-limited data centers, tight customer power budgets, and a product strategy that essentially demands annual hardware releases. On the flip side, Subvertio AI proposes a completely different vision. They're talking about a post-scarcity architecture backed by massive hydrogen and oil microgrids. Instead of treating processors like disposable engines that you just throw away every few years, Subvertio wants to build them like permanent hydroelectric dams. We're talking about one-terminal hardware architecture where only the software needs to evolve.
Section 1. The contrarian processor design, moving to 90 nanometers.
And this brings us to a massive shocker in their engineering strategy. While the rest of the semiconductor industry is fiercely fighting over 4-nanometer and 3-nanometer leading-edge tech, Subvertio AI is deliberately building on a mature, older 90-nanometer global foundries node. Let's unpack why they're doing this, because it's fascinating. Those 4-nanometer chips come with astronomical costs. We're talking up to $20 million just for the mask sets, and they are heavily capacity constrained. Plus, they face incredibly strict export controls. Subvertio, on the other hand, is relying on a 100% US fabricated 90-nanometer node. Neutrally speaking, this acts as a massive strategic procurement advantage. It allows them to legally serve global markets that are trying to avoid those export controls. By tapping into a fully domestic supply chain and utilizing physics limit clocking, completely unchained from power ceilings, they just bypass the whole bottleneck of leading-edge capacity. So, the absolutely crucial question here is, how do you make an older 90-nanometer chip competitive in today's intense AI landscape? Well, the answer is ternary compute, specifically the 1.58-bit class. Instead of relying on traditional, super power-hungry, high-precision floating-point math, which older nodes really struggle with, Subvertio uses a native computation method based on just 3 states. And it turns out for large language model inference workloads, meaning the actual generation of responses rather than the initial training of the model, this highly efficient method makes mature 90-nanometer silicon completely viable and incredibly competitive.
This brilliantly illustrates the math behind that strategy. Steve Favis, the founder and CTO of Subvertio, points out that a ternary Mac, which is the core calculation engine of the chip, is roughly 10 to 30 times cheaper in both transistors and energy than a traditional floating-point Mac. By stripping away those high-precision math requirements that you literally only need for training AI models, Subvertio completely neutralizes the node disadvantage of older silicon. They aren't trying to beat 4-nanometer chips at training. They're aggressively optimizing for the absolute highest volume workload, which is inference, actually running the models out in the wild.
Section 2. Crushing the benchmarks, a theoretical takeover.
When you pair this ternary architecture with a design that assumes truly unlimited power, the theoretical performance gets absolutely wild. We're talking about a microfluidic cooled chip pulling over 1 kilowatt continuously. Just look at how the specs compare to NVIDIA's flagship B100. The B100 hits 9,000 TFLOPS of compute power and 192 gigabytes of high bandwidth memory capacity. But Subvertio's unrestricted architecture projects a theoretical 10,000 TFLOPS. And the memory dominance is even crazier. Subvertio scales up to a massive 288 gigabytes of memory capacity and 12 terabytes per second of bandwidth. Why? Because they're employing massive microfluidic cooling, meaning there is zero thermal throttling. They literally do not have to dial back performance to keep the chip from melting down.
Now let's translate those specs into theoretical workload performance gains against the B100. We see a 62% jump in mixture of experts dispatch and a massive 65% increase for complex 4K video generation. But the real standout? A 100% performance gain in long context models. This is driven by what they call massive SRAM locality, meaning Subvertio puts the memory directly on the compute tile. For you and me, that means instantly processing massive 300-page documents without a single hiccup. The processor has immediate access to the data exactly when it needs it.
Section 3. The Business Master Plan, a reality check.
It's super easy to get lost in the theoretical specs, right? So let's bring this narrative right back down to earth. Subvertio AI is a standalone processor company, raising capital. The documents make it very clear that this processor business is completely separate from the $130 million fabrication plan proposed by their broader corporate group. The investment we're talking about here is strictly in the chip design and the workstation product. It's fabless and fully grounded. They're targeting a $21 million Series A allocation. This covers the production tape-out, finalizing the design for manufacturing, along with getting first silicon, advanced packaging development, EDA tools, and expanding the team. And what's absolutely fascinating is the form factor. Over the next 24 months, their goal is to turn validated test silicon into a shippable, liquid-cooled workstation product that actually fits inside a standard ATX computer case. They're building a field-replaceable unit for standard desktop footprints, not just giant specialized server racks.
And they're already moving way past the conceptual phase. $85,000, $862. That is not an estimate. That exact dollar amount is the firm fabrication quote they already hold from CMC Microsystems for their Proto 1A test chip. Their core logic and a slice of their production compute fabric have already been successfully placed and routed on the real GlobalFoundries 90nm process. They aren't just sketching ideas on a whiteboard, they have real Foundry quotes in hand.
So, taking a look at their 10-year pro forma roadmap, you can trace the financial timeline. Starting with that Proto 1A validation in 2026, they plan for pilot shipments to begin by 2028. The model projects reaching a positive EBIT, meaning they're actually turning an operating profit by 2032, and climbing all the way to a projected $630 million in revenue by 2035. And the math here is incredibly practical. That $630 million figure relies on capturing less than 0.5% of the total addressable AI chip market. They literally do not need to defeat the industry giants to build a highly profitable, self-sustaining business.
As we wrap up today's explainer, I want to leave you with this final, striking thought directly from their white paper. Energy is the ultimate compiler. Power becomes a creative substrate. In our current world, engineering is entirely about minimizing power. We optimize per watt, but Subvertio asks us to imagine a future where energy is so abundant we optimize per possibility instead. What does the future of AI computation truly look like in a post-scarcity world? When energy is no longer the bottleneck, what will we be able to build?